Hey everyone, Dream K here. Now, whether you're just starting out your coding journey or you've been at it for a while, we all make mistakes. That's part of the learning process. But there are some common pitfalls that can really trip you up and lead to some frustrating debugging sessions. In this video, we're going to dive deep into 10 of these programming mistakes that you definitely want to avoid. We'll break down why they happen, how to spot them, and most importantly, how to steer clear of them. So if you're ready to level up your coding game and save yourself some headaches in the process, buckle up and let's get right into it. First up, we've got infinite loops. These can be a real pain, right? Basically, an infinite loop is like that song stuck in your head that just keeps playing on repeat, except instead of a catchy tune, it's your code running endlessly. And trust me, you don't want your computer stuck in that loop. The most common culprit here is forgetting to update your loop variable or setting up your loop condition incorrectly. Like, think about a for loop. If you don't increment your counter or you mess up the condition, your loop's never gonna end. Next up, let's talk about type mismatches. Now, programming languages often have different data types like integers, floats, and strings, and when you try to mix and match these types without being careful, you can run into some unexpected results. Imagine trying to divide an integer by another integer but expecting a decimal result, or trying to perform an operation on a string as if it were a number. These type mismatches can lead to logic errors that are tough to track down. This next one's a classic, and it trips up even seasoned programmers sometimes. It's the confusion between assignment, using a single equals sign, and comparison, using double equals signs, equal sign. It's so easy to accidentally use a single equals sign in a conditional statement like an if statement, thinking you're checking for equality when you're actually assigning a value. This can totally throw off your program's logic. Now, we're entering the territory of undefined behavior, and this is where things can get really unpredictable. One prime example is dividing by zero. It's like trying to divide a pizza by no one. It just doesn't make sense, and your program might crash or produce weird results. Another example is modifying a variable multiple times within the same expression. The order of operations can become unclear, leading to unexpected outcomes. Working with files is a common task in programming, but it also comes with its own set of potential pitfalls. One of the biggest mistakes is forgetting to close your files after you're done with them. It's like leaving a faucet running. It can waste resources and lead to problems down the line. And speaking of files, always make sure to check your file pointers before using them. If you try to use a null file pointer, you're headed for a crash. Preprocessor macros can be powerful tools, but they require careful handling. One common mistake is forgetting to enclose macro arguments in parentheses. This can lead to unexpected results, especially when your macro involves expressions. Remember, macros are basically text replacements, so if you're not careful with parentheses, the order of operations can get messed up. Think of compiler warnings as your code's helpful friend, trying to point out potential issues before they turn into major problems. Ignoring these warnings is like ignoring a check engine light in your car. It might seem fine for a while, but it could lead to bigger headaches later on. Compiler warnings can alert you to things like unused variables, uninitialized variables, or mismatched types, all things that can cause subtle bugs. Alright, so you've run into a bug. It happens to the best of us. But here's the thing, effective debugging is crucial. One mistake is not using a proper debugger. Debuggers are like X-rays for your code, allowing you to step through line by line, inspect variables, and pinpoint the source of the problem. And please, avoid the temptation to rely solely on printf statements for debugging. While they can be helpful, they're not a substitute for a real debugger. Hard-coding values directly into your code might seem convenient at first, but it can make your code a nightmare to maintain and understand. Imagine trying to figure out what the number 42 represents in your code months later. It's like trying to decipher a cryptic message. Instead of hard-coding, use constants or macros with descriptive names. This makes your code more readable and easier to modify. Last but not least, let's talk about function return values. Many functions in programming return values that provide important information about their execution. Ignoring these return values is like making a phone call and not listening to the other person's response. For instance, functions like scanf, malloc, or file operations often return error codes or status indicators. Always check these values to ensure that the function executed successfully. And that's a wrap. We've covered some of the most common programming mistakes that can really trip you up, from infinite loops to ignoring compiler warnings. But remember, the key takeaway here is to learn from these mistakes and develop good coding habits. By being mindful of these pitfalls and following best practices, you'll write cleaner, more efficient, and ultimately, bug-free code. Thanks for tuning in, and don't forget to hit that like button and subscribe for more coding tips and tricks. Catch you in the next one.